Hi there, this is Daniel, and you are going to get coded. In this video, we are going to continue our journey through dictionaries, and as you can see on the left side of my screen, dictionaries are key value pairs. And this same page I had in my first video, part 1, when you want to declare a dictionary. So declaration, initialization, and there was something else there. If you haven't checked that video, please check that video first, because that video explains all the things that you might want to know in order to declare a dictionary. So to create an instance of the dictionary class that is built in .NET. But in today's video, we are going to talk about methods. So all the popular or more commonly used methods from the dictionary class. And afterwards, we are going to also call some methods to sort a dictionary, and we are going to sort a dictionary based on values and based on keys as well. So you can sort by values or by keys depending on your use case, depending on how you want actually to sort your dictionary. Okay, so let me try to go to that specific page. So I have to go to C# dictionaries, and this is not going to open the way I want to. Let's try to go like this. So this was from yesterday, declaration, and then the methods that we are going to go through today. So before we start talking about the methods, let's try to create a simple dictionary. We are going to use the same dictionary that I actually used in my previous videos. So in the part 1 and part 2. So let's create a new project because I don't have that one anymore. So file, new project. And we are going to create a simple console application, and this is going to be named dictionary methods. Again, a simple console application, and I chose .NET Core because this is like the way to go from now on, at least from my point of view, because .NET Core is portable. It can run on any platform, and this is like I think right now is the version 3.2 or something, and Microsoft puts a lot, like almost all their work into this, because they understand the value of actually having a source code that is capable of actually running on multiple platforms. Okay, so now that we have our console application, let me try to write the code that you see on the left side. So this code actually declares a new dictionary and initializes it with 4 values. So we have peach, grape, lemon, and coconut. Again, this is a store. We are imagining, or we are trying to model, this is like the name, to model real life into code, because this is object-oriented programming. So we are trying to model how a store, how an inventory would look in code. And I chose to model this real life concept through a dictionary. And this dictionary contains a string, which is the key, and a double, which is the actual value. So this is the type of the fruit, as you can see here, and this is the quantity. So how many kilograms we have for each of these fruits. So let's try to create that. We need var in order to declare a new variable, and then store. We need to have the name of the variable. And again, just for you to remember, whenever you declare local variables, so variables inside methods, they have to be uppercase, they have to be lowercase, so no uppercase. They have to start with a lowercase letter, as you can see here. And also before that, you need to specify var. You could also use the exact type, so the declaration type, in our case dictionary of type string and double. But for our short example, again, we can use var, and also on the same line we actually specify the type that we are going to use for our store dictionary. So it just doesn't make sense to say it again in our code. So this is going to be a new dictionary, and you can see that I actually don't have it, so I have only my namespace. So press escape and then control dot, and this is going to prompt you to actually add a using statement. So this is a namespace. In this namespace, we can find many collections, out of which we have our dictionary. So the dictionary class resides in a system.collections.generic. And then we need to pass our string and our double. And then we can initialize it. So it's the exact same way I've done it in the first video, so part 1 of dictionaries. I initialize it with some indexes. So I have the peach, which is the key, 15 kilograms, and then you need to put comma. So you have a comma separated indexers, or comma separated items declared as indexes. Then you have grape, which is going to be 23. Then we have lemon, and don't forget you need to use the square brackets. So these square brackets are used for indexes, so you are able to actually see those very often in code, because when you have collections or arrays or even indexes, there are some things as indexes for a class, you need to use these square brackets. So this is like a way to just point to you that, oh, we are dealing with some indexes right now. And then we have lemon. Let me try to continue on typing. And then the last item, we have coconut, which is 10. And then we can put the semicolon afterwards. So after our initialization, we can end our statement. So this whole thing right here is a statement. We have the declaration part here. So we declare what type, what instance we want to initialize from. And then we have our initializer over here with our 4 items that we want to put inside our collection. Okay, so if we try to add a key which already exists, the argument exception is thrown. And I went through this, I think, in my second video, part 2 or part 1, I think. Again, indexes, these indexes have to be unique. So dictionaries must have unique keys. They have to be distinct. So you are unable to add a key again with the same value. So the same key inside the dictionary. Let's try to use our add method to try and add a new value. And because I've went through this once, you can watch in my previous video, so you don't have to see this again. Right now we can just use the try catch block to actually safely add a new value inside our store. So if I say try, and then I can have argument exception, this is going to catch the argument exception if this is thrown. So store.add, let me try to add the peach. So the peach fruit type, and then 21. So I want to add 21 kilograms of those. In this way, because I also want to teach the try catch block in this example, because I believe it's like a good example to actually teach this. We have a dictionary, as I said, and then we are trying to add a new item inside our dictionary. You are able actually here to see that, oh, we have already added the peach fruit type inside our store dictionary. So we know that this is going to throw an exception. But sometimes this code over here, you cannot see because it's far way up or in another class or something like that. Doing something like this is unsafe because you never know. So only like this. This is why we have to put it or to surround it with a try catch block. So this unsafe piece of code, this unsafe statement has to be inside the try catch so that it catches any exception that this piece of code might throw. But in our specific case right now, it does catch the argument exception, but it throws it again. So this code does absolutely nothing more than just having this statement over here because we are throwing the error. The whole point of the try catch is to not throw, but to do something about it. Other times, because you have several files and several classes and stuff like that, you don't want to actually do work here, so you might want to throw. You might want to throw this specific argument exception, or you might want to throw a new, I don't know, fruit exists in the store exception, so you can create this specific exception, and you can pass in some values and stuff like that, and you can also pass in the inner exception. We are going to go through this in a later video, but to just explain or show how you want to go about that one, here you would just have our type declaration. So we have argument exception, but also you can name this. So right now we have this local variable, and you can see that it is declared but never used. But we can copy this one. So EX, which stands for exception. If we remove our parentheses and we start it again, okay, that didn't work. Okay, let me try to press on Control Space. Doesn't work either. Oh, because this class here is not defined. Let me try to roll back because I want to show you something else. So exception and then parentheses. You can see that we have one of 3 constructors. So this exception class exposes or has 3 different constructors based on the number that we have over here. So the first constructor has no parameters, so you can actually initialize the new exception by giving no parameters. So this doesn't require you to pass any argument, and it just creates or initializes a new instance of the exception class. The second constructor, the second overloaded version, is this with the string method message. So you can actually pass the message that you want for this exception. So the whole point of exceptions is actually to show you or show the developer, other developer, what happened in your code. So it's very important for you to have a message inside inside your exception, because this message actually contains the reasoning, so the fault, the why behind why this exception was thrown. And the more descriptive you can be with your message, the better it would be. And also, being a string, you can write like some fixed constant string message, or you can actually have a dynamic one, and you can pass in some values which were added. For example, peach, you can have like the key and then apostrophe is peach already exists in the store, so you can have your own message. But if I scroll or actually press on the down arrow, you can see the third overloaded version of this exception constructor, and you can have a message, and also you can have an inner exception. In the inner exception, you can pass the exception that was previously thrown, and that is actually at the core of it. So whenever you are thinking about exceptions, you can think about a stack of exceptions. So you have the core root of the exception that was first thrown, and then because you have many try catches, that specific method that threw the exception is going to go into the try catch, and that try catch can put the exception inside the stack. So you are going to actually stack them up, and at the end, when the program actually crashes, you are able to go through all the stack of the exceptions, and you can see them. And let me try to actually do that right now, because these exceptions are very important. So let me try to see. We need a message, and then we need to pass in the inner exception. So our message is going to be like this. The fruit type already exists. So this is our message in the store. And then our inner exception, we need to pass this specific one, because this one, once it's thrown, it has actually itself the inner exception that this add method threw. And then we need to end this with a semicolon. What I want to show you guys is that this message here is fixed, is constant. It doesn't actually give us a lot of information. So we need to go inside our exception over here and try to find the message of that one. Maybe it tells us about the peach. what I want to do is actually have a dynamic string. So I want to pass in the key, and not necessarily the value, but the key, to actually help us or to show exactly what key ruined our adding method. But because right now this speech over here is inside our try block, this is not actually the way to go. And you saw this in my previous videos when I was explaining that you should not have strings like this in your code. These are called magic strings, and these are prone to errors and bugs because sometimes you may have several occurrences of this string, and you might mess things up. You might forget. You might want to change them. For example, if I spell it like this, it's going to ruin my whole code. So the whole point is to actually extract this so that you will not be in danger of having bugs related to strings, because they can be like really ugly, because you might have like several classes and it's just so difficult to actually manage all of them, and you should not do that. You should not freaking do that. So let's try to actually extract the peach from here, and let me try to think how we should go about this. Again, this is like a var. This is the peach type, so peach type, and the peach type is the actual peach. You don't need to do anything else. So this is like the peach type or the peach key, and then we can use that one here. I can also remove the code that I have on line 20 because this is not used anymore. That was just for explanation purposes. And now you can see that I have the peach type passed over here. Also, I know I'm using this here, but this example is just that, an example. I'm not going to actually change all of these into a variable. Or what I could have done is to just move this one up here and then replace all of them one by one. But again, this is just an example. In real code, you might not have an initializer because you might not know exactly what type of items you want, or you might not want to actually specify them manually as this. So these could have come from a database or from an API or from something else. So it's not quite common to actually have a dictionary declared like this with all this data, because again, we don't want data in our code per se. And this is like a whole other discussion that actually I don't want to go into, because this is like how you go about writing code. For some developers, code means logic. So you want to write code that actually performs on specific data. So that's like at the core of functional programming. So there are several paradigms of programming. You have procedural programming, you have functional programming, you have object-oriented programming, and also you have reactive programming, which is like one of the latest that appeared, but it's not as used because it's just specific for some use cases. So you cannot just use reactive programming for anything or for everything and to just create an application like that. I'm not sure you could do something like that. But what I wanted to say is that one thing that you should know, for example, from functional programming is that you want to write functions that operate on data. And right now in our code, you can see that from the lines 14 to 17, we have some data there. And some programmers would argue that this is data and this should be outside your code. And this holds true for many reasons, because data should reside again in a database or in a CSV file or in just like a simple text file if you want to do like that. Data should not just be inside your code if you don't have a clear purpose or a clear reason for why you want to do that. But this can put you on a very difficult path, because if you want to fully separate your data from your code is going to become a little bit a little bit more complicated to understand. It's going to become abstract, and you would have only logic, which is very good. You are going to have only logic in your code. But sometimes having data actually describes better your code, shows what the code is about. So even though there are two types of school of thoughts about writing code in terms of like having data in your code or not, and only relying on logic, the best way, and this is like a general advice in life, is to just see what works and combine them. You know, I've never found that one paradigm holds or has all the things that I would want. There are so many things that I actually like about functional programming, and so many things that I actually like about object-oriented programming, and I'm going to describe them as we go through our videos. But in general, you need to like just see through it and try to combine these two paradigms, trying to make the most out of them. And you have all the reasons to do it in C#, because C# has both object-oriented concepts, because it is like first-hand an object-oriented programming language, but also due to the latest versions of C#, there have been many features, many functional programming features added to the language to make it more functional. You are able to declare functions as local variables. You have shorthand functions, so the arrow functions, which you have seen maybe in other languages. There are some classes for immutable data structures inside C#. So there are quite like a few things that you can use C# for, not only for object-oriented programming, but also for functional programming. But again, going back to our code over here, we have a store, we have a dictionary, and this dictionary has some data. In our example, this is good enough. We don't have to change anything else. But in other examples, you might want to separate, you might want to extract the data. And some developers also might argue that, oh, maybe we have an enum with some fruit types, and we want to actually operate on those enums. And enums are a special kind of case, because these enums can hold a collection of values basically, and you have also a key and a value. These enums are special, but again, the same principle actually applies to them as well. So you still have data in your code. But if you want to do it that way, you can totally do it. For example, in one of my projects, I actually used enums for my data, because it was just a small project. I didn't want to use a database. I didn't want to use any of that. And I just used enums to actually store some data and to judge or to write my code or write my logic on that data. It's perfectly fine. Again, whenever you write code, whenever you want to create an application, or whenever you want to develop a project, just think about your use case. Think about how big of a project it is. Okay? So having said all of that, let me try to put this back. And I hope like you find this advice useful, because again, I'm not trying just to teach you code. I'm trying to prepare you for what you're about to see. Because when you go out there, when you go to Stack Overflow, when you are trying to read tutorials, and when you are going to watch other videos from other developers, you are going to see that there are so many opinions. And I'm not saying like my opinion is right. I'm just saying what I am doing in my day-to-day programming life. And this is the way I go about my own code. I'm trying to learn every single day. I strongly believe that as a programmer, as a developer, you need to invest time daily in actually perfecting your skill set, expanding your knowledge, reflecting on what you know, adjusting your thinking pattern, trying to understand why you might be wrong about certain things, and trying to look as objectively as you can over a piece of code, or when another person comes with some feedback or comes with a different version of implementing a certain thing in code. So this is like the mindset that you want to have. I know some developers have grown tired of actually learning new things, but it's just like that. Okay, so let me try to go on with this example. Right now, what I wanted to do is that I want to make this string dynamic. So this right now is not dynamic, it's just like a constant string. What I want to also pass in what key actually threw this exception. Right now, because I have it outside of this, I can actually use this speech variable over here and put it somewhere inside. But we need to make this, or to transform this into a string interpolation expression. And we can do this with the $sign. Right now, this is a string interpolation expression. And inside here, we need to see where we want to insert our key. So the fruit type, we can put it here, peach. And we can put with apostrophes, already exists in the store. And then we throw our exception. So let me try to run this code. Also, in order to do that, don't forget we need console.read key. It's going to keep our console open until we press a key. Very convenient. Again, this is what I'm talking about, writing declarative code and also code that actually expresses the intent. Just by reading this line, you can see console.read key is very expressive. This is why you need to spend time actually naming your methods. And that can be like the worst part of programming, because sometimes you don't know. Sometimes you just don't know how to name a method or a class. But my advice is to just think a little bit for like 5 seconds. Come with the best name that you have right in that moment after 5 seconds. Use that name. Continue on implementing your class. So continue on implementing your function, your method, because we are in object-oriented programming. Continue on with that, and you are going to find out how you actually want to name your method. So don't just like, oh my gosh, now I have to spend like, I don't know how long to come up with a name for my method. Don't do that. Just continue on implementing. That name is going to come to you afterwards. Okay, so let's try to run this console application. And you can see that this threw an exception, and we wanted that. We wanted to see like how the exception was thrown. And you can see the message, the fruit type peach already exists in the dictionary. So this is our custom message for our try catch. And it is dynamic because I passed in the key that actually threw this exception. This was the reason why it threw, because it already exists. And also you can see underneath that we have an inner exception. And this inner exception is the argument exception. So this was our own exception that we threw, but the stack inside it, so the level down, one level down, is the argument exception, this one that was thrown by this add method. And you can see it has also a message. It has an item with the same key has already been added, and the key is speech. This message over here already told us, oh my gosh, the peach was the fault. And it did the exact same thing as we did over here. You can see. But sometimes you might not know. You might not rely on other people methods or exception handling per se, because maybe .NET Core might not have added this one. So this was not added as the key. So you might want to go to actually display your key too. Also, if this was not opened, you can also go to the exception itself. You can hover on the exception, and you can see that I have like a small collapsible arrow over here, and this tells you a lot more about what happened about that specific exception. You can see that this exception over here doesn't have an inner exception, so the stack has ended. This stack only contains 2 of them. The first one, the argument exception, the second one, the exception that we actually threw over here. And also it has the message and other things. Let me try to open that again. It has several properties that you can see here. The message, I don't know, you only use, like, out of all of these, you are going to use the inner exception. This is very important. You are going to use the message and some parameter names as well, so you might pass parameters to exceptions. We have not done that, but these three are the most important. You don't use the other ones. Like, I've not come to any, I've not used these ones at all. Okay, let's stop the application because it crashed. Right now, I don't want to throw this. Let's try to actually remove this whole thing. And what I can show you guys right now is that because I'm putting this inside a try catch, I'm catching the exception, but then I'm not doing anything. This catch right here just catches the exception and keeps the program from not crushing. So it doesn't do anything about that exception and it moves on. You could also say CW, so and tab for console write line. You might want to display the exception message. So exception.message is going to display it to the console. The extent of this is actually displaying to the user. So if you are creating a website, an ASP.NET Core application, you might want to display this as a message to the user. For example, you have a form, and when the user submits the form data is going to be passed to the server, and the server actually goes through like, I don't know, the email, the password, and if something is wrong, the server knows how to return back some errors, and then you are going to actually display those to the user, so that the user would make the appropriate changes in order to have valid data in the form. If I'm going to run this right now, you can see that we have the message thrown and it did nothing, because right now the store already has the peach, so we didn't add it anymore. And actually you couldn't have seen that in the console because I don't have a for each. So let me try to just quickly write a for each. We have a store, and then we have item.key. Let me try to just print out the key. If I'm going to the key and the value. So right now you can see that we have only the keys, so peach, grape, lemon, and coconut. We can also have the value, so plus for concatenation, and then plus we have item.value. This plus over here is used for concatenation, so for putting strings together. This is what concatenation means. And we want to append a space, and we want to append the value too. So let me try to run this, and you can see that we have peach 15, 23, 8, and 10. So the peach didn't increase or didn't change because we don't have an increase here, which have just changed. Peach remained to 15. So our code works. Let me try to move on. So that was the add method. The add method again is important to make sure you understand, because it needs to be put inside the try catch. Also inside .NET you have store.add, TryAdd. So you are able to actually try to add a new key. Let me try to say peach type, and then 21. And this is going to return again a boolean, true or false. If the key already exists, it's going to return a false. If the key doesn't exist, it's going to return true, meaning that the operation was successfully what's the verb? I don't know the verb for that. The operation succeeded. So this is the alternative of what we wrote here, and it actually uses the boolean value instead of exceptions. So that's the way of like going about it. This is called defensive programming. This is another way of writing your programming, your logic inside your code. Some people again argue that this is not the way to go about it. Some people find it useful. So you can either use exceptions or you can use booleans. In some languages, there are no exceptions. In C# we have exceptions because Microsoft has decided to actually have those built in the language. People view them as evil because you should not have exceptions. You should just handle them with boolean values and stuff like that. Again, I'm so grateful that C# actually provides us with options, with alternatives, and you can go either by using this one or by using this one. If we are going to run our project, you can see that neither of them crushed our project. Both of them tried to add the peach type, and because it was already in the dictionary, neither of them actually threw the exception, because first we have the try catch, second it has a try catch already by default inside the .NET framework. Okay, now let's focus on our ContainsKey. So I can just like move on and write my code afterwards. So the ContainsKey, again, we could have gone with this approach. We would be able to perform our operation, our add operation, with the TryAdd or the TryCatch. But also we can check before with ContainsKey, for example, if the key already exists. So the key that I want, var key speech, and actually we already added, or we already declared the speech key over here. So we have the peach type over here. Just leave it like that for the example. And then we have the ContainsKey. Let me try to write it the first time as I have on the left side, and then we are going to replace it with an if. And you are going to see like the difference. So store.ContainsKey. So the store itself has a method called ContainsKey. This method comes from the dictionary class. And this ContainsKey checks, as the name entails, or as the name states, if it contains the key. And the key that we want is this. So this is going to check. If the key already exists, it's going to return true. Otherwise, it's going to return false. We can check that by using the ternary operator over here. This is called the ternary operator because it has 3 different parts. So it's an operator that has 3 different operands. It has the expression, it has the statement for the true value, and the statement for the false value. So you have 1, 2, 3. The first one is the false, the second one is the first one is the true, the second one is the false. Oh my god, I'm so sorry. So true, false. Question mark is for the true, so this is the if part, and then this is the else. So we can say if ContainsKey, if this is true, then store key, give us the key. Otherwise, we are going to display with string interpolation, and also we have the @ key. The key peach doesn't exist. Okay, and then we want to actually put this inside a new variable. So exists, or key exists, key exists, key exists, and then we need an equal sign. Okay, let me try to see why this didn't work. Oh, because I'm returning a store key. Type of conditional expression cannot be turned because there's no expression implicit conversion between these two. So, of course, there is not. If this contains key, let me try to actually fix this error, because again, this is like live programming. You might want to have the knowledge of actually how to go about this. So whenever you have an error, try to read the message. So this is like the first step. Type of conditional expression cannot be determined because there is no explicit conversion between double and string. So basically, right, this code actually tries to give us the value, and the value right now is double. The string is the key. The key is string, but the value that we put inside that item is double. And this one returns a string. So there is a difference between double and string. There's a difference in type, in the type that we return from these different branches. It has to be the same type. Both branches need to return the same type. Otherwise, it doesn't work. This is why this variable over here, actually, if we hover over, has a question mark, because C# cannot infer what type we want to get. There are ways to go about this. Again, depending on your logic. What do you want? Do you want to see key exists and is going to return true or false? If we want something like that with key exists, we can have like true or false. And you can see right now, if we hover over, we have a boolean. Also, because this returns already a boolean, we might not want to have explicitly true and false keywords inside our statement. So we could do something like this. This is again a boolean, because the value returned from ContainsKey actually gets the key, or gets the boolean expression. What I want, actually I don't want key exists, I want the key. If I want to go about that right there, the key is going to return, or the ternary operator should return the key instead of the value. And then we have a message, key doesn't exist. Let me try to rename this to found key. So you can see right now the type is string, the found key is either the key or a message. That could be the way to go about it. You know, ContainsKey, we can judge based on this one. Also, you might want to get the value. So found value by key. And then we can pass in the store the key, and it's going to return a double, but we can also say to string, and it's going to give us the string, and it's going to be the string representation of that double value. There are many ways to go about this, but the main point of using ContainsKey is to use it inside an if statement. So in real life, you might have something like this: key exists, and you have store.ContainsKey. We want to pass in the key, and then if key exists, we want to do something, and else you want to do something else. If key exists, just display the value, because the store already has the value inside or at this specific index. Otherwise, if key doesn't exist, you can go ahead and add it, or you can just say the message key doesn't exist. And also we can pass the key actually which didn't exist. Let me try to put a $sign to make this as string interpolation, and then we have the key. So let me try to run this code right now, and you can see it returned 15. 15 was from here, the found value by key. The 15 is the actual value of the peach, so how much we have, the quantity. And it didn't return doesn't exist because the key already exists. Also, what we have on the second line is if ContainsKey, if key exists, then we should put this one. Oh, that's my fault. Let's try to read the code again. Oh my gosh, I just said something wrong. If you could have cut that. This one over here displays the message that we saw here, so 15. This one only saved in the found value by key, but we forgot to actually print that. So this is going to just put it in here. So console write line, let me try to say console write line, found value by key. If we save this one and run it, you can see that we have 2 times, because the first time we only put it inside the variable, but we forgot to actually display it. And you can see that we only are on the true branch because the value exists in the dictionary. Okay, let me move on, because I think you understood the ContainsKey. You can also use the ternary operator. Also, what I forgot to teach you or to show you is the ampersand sign. I use this ampersand sign, but you can see that inside here I have an extra pair of quotation marks because I want to, instead of displaying the message, yeah, that didn't work. Let me try to close that one. I want to display this message. What should I do? Let's try to say, let us change the key. Instead of that one, I want another fruit, I don't know, cherry. And if I save it and run it again, you can see key cherry doesn't exist, but I want to actually surround the dynamic parts of the string with some quotes to make it more visible, to make it easier to understand, easier to see for other developers. It's easier to see like that. So I could just put inside the quotation marks. Okay, right now it says that doesn't work. Why this code works here and doesn't work here, I'm not sure. Because you should have worked. Yes, I'm so sorry. Only assignment. Okay, so I thought whenever you are using the @ sign, you could actually use the quotation marks, but it doesn't prove to be like this. I don't know why my code actually is like this on the left side. Maybe it's my fault. If you want to put quotation marks, you need to put them twice, so then you don't need these ampersand. I thought ampersand in C# was enough to do it. Oh, right now I see it. Yes, it is enough to, it's not enough to just put the ampersand. So you need to put the ampersand, and also you need double quotation marks. So you need to put them double. If we are going to run our code right now, you can see that we have cherry as that. Yes, so I'm learning too. I'm so happy, you know, it's not only you who learn, but also me, because these things you can forget. So yeah, you need to use the ampersand because this kind of transforms the string into something more constant. In a way, it's not constant because we put inside the key, so it's kind of dynamic, but it makes it kind of constant. And then you can have your double quotation marks. Okay, let's move on. We have two more methods. We have the remove, and this is just simple. We have store.remove, and then you can remove, I don't know, coconut, because we already have that one. And let me try to see what it returns. It returns Boolean. So I believe it returns if the operation succeeded. So if it succeeded, or if this succeeds, it's going to return true, otherwise going to return false. Let me try to put this one before the for each, because I want to see if this is capable of actually removing the coconut from our store. And you can see right now we have only 3 items inside our store collection. We have peach, grape, and lemon. So only these 3 items and without the coconut. Awesome. And the last method that I want to, oh, it's not a method, it's a property, is called count. Let's try to go down. So in order to see how many items you have in a dictionary, you can use the count property. So we have store.count. And this property over here, you can tell that is a property because, first of all, you don't use the parentheses to actually call it as a method. And also you have the specific symbol, which is the key, this key over here. This shows that we are dealing with a property. And this gets the number of key value pairs inside our dictionary. So if we say count, this count variable is going to be of type int, and it's going to return how many items we have inside our dictionary. Let's try to print that to the console. So count, and let's try to run this. And you can see we have 3 because we already removed our coconut from our previous method with the remove one. You can see that here I have another name which is more declarative. So again, whenever you write code, try to make it more declarative. This is not good. Like var count what? You might have this count variable, or you might want to use this count name in other parts of your code. So this is not specific. This is not very declarative. So let's try to press F2 and say total fruit types, because this is what this variable actually holds. It holds the total fruit types. And then you have the count, and you display it like that. The last method that I want to show you guys in this video before I end it is the TryGetValue. Sometimes you might not know if the value exists. You could use the ContainsKey. So if the key is contained, just give me the key, as I'm doing over here. So here I'm getting it through the index with this structure over here. I'm trying to see if the key exists. If the key exists, get me that key, or give me back that key based on the index. But you can also use the TryGetValue, which is the alternative of this whole bit over here. So you don't need to use an if statement anymore. Let me try to write that down. So what do we need? We need to type TryGetValue. We need to pass in the value that or the key that we want the value for, and then you can see that it has a second argument that it needs, and it is an out argument of type double, which is the value and the quantity. So this is the value. So TryGetValue by the key and put the value inside this variable. So the key and the value, and I'm going to cover the out keyword after I write this example. So store that get value, TryGetValue is going to say lemon. This is the key, you can see it here. So it wants the key, and then it's going to put that output, that result, that value inside your variable. So I want you to put that value inside this quantity variable. Put it here. And then we can just display it to the console. So quantity. Let me try to run this example. And for the lemon, we have 8. And indeed, we have 8. So the quantity 8 for the lemon is here, which is awesome. Now, we have the out keyword over here. In C#, you have two ways of passing arguments. You pass them by value, or you pass them by reference. When you pass them by value, you are only interested in the value that that variable has. For example, you have an integer with the number 3 inside. We are only interested in that. But if you are also interested in the part of the memory, in the part of the RAM memory that specific variable resides in, because again, we are programmers, but we are dealing with hardware as well. Whenever you declare a variable, that specific variable is going to reside, is going to be located in your RAM memory, and C# is going to allocate the necessary, the required space inside the RAM memory, and it's going to allocate that memory to your variable. When you have an object, for example, that object is going to be placed in the heap memory. That's like the place for objects. And then you can use the reference or the out to actually pass them out as that. You know, you have the reference, the ref keyword. So this is like what I'm talking about, the ref. When you have the out, it means that I'm passing the argument, I'm passing this variable, and whatever happens or whatever changes you have inside the TryGetValue being performed on it, keep them and let it be outside. If I were to pass this only like this, quantity, the quantity could be passed inside, but because this is a double, this is a value type, it's not a reference type as an object, this is a value type. I want to make this, to transform this into a reference type, and I can do that with the out keyword. The out keyword makes this double, or makes value types, and you have many different value types. You have integers, doubles, booleans, floats. These are value types. Whenever you pass them, and whenever you pass them to a function or to a method, and you change the value, they forget when they are out of the method. They forget about that. They forget about the operations that you put inside of them. But when you have this out, every single operation that you put in or you perform upon this specific argument, this specific variable, is going to be remembered when you go outside of the statement. So when you are on this line, on line 60 over here, the quantity variable remembered all the operations that you did to it, and it's going to have the updated value inside. So this is why we need the out. Okay, you are going to see the out keyword many times with TryGetValue, because basically inside the TryGetValue you have by default a try catch, and try catch has like these two branches, and you have like some levels, and it just makes sense to just use the out keyword, because you try to get the value. This method returns boolean, returns true and false, doesn't return the value that you were looking for. So the only other way to actually give you that value is to just use the out parameters, just to pass it back into the argument itself that was passed in. Because from a function, you can only do these two things. You can return back, or you can get the result from a function by returning the value. But right now we already have done that, so we have boolean. You could put it inside the argument, so you can pass and you can reflect the changes inside the parameter itself, or you could just have this method change the outer scope. So this is going to have some side effects. This comes from functional programming, and these side effects can hold in the changes. So this method is going to be able to change things outside, which is not advisable. This is prone to actually make your code harder to understand and prone to bugs and errors. Okay, so I hope you understood this part over here as well. This is a little bit more complicated, but again, I cannot just move on and then don't explain all the different parts of the code, because there are so many things that you need in order to write a specific piece of code. Even though we are talking about dictionaries, we are going to deal with out parameters, we are going to deal with try catches, we are going to deal with ternary operators and string interpolation as well, as you see here. So there are many things that you are going to use, not just dictionaries. And I see so many examples trying to keep it just simple, and it's just like, why would you want to keep it simple, or just not really simple, because I do like simple things, but just so abstract and so like low level. Like, why would you want to use low level? Because in real life you are going to use all these different structures, all these different concepts of the language in a combination. You are going to combine them. You are going to make your code reflect the real world, and real world is kind of confusing. Okay, so if you like this video, please thumbs up, or if it helped you. Again, I am more than grateful if you are writing anything down below, just your feedback. I am an objective person myself. I know how to get criticism, and I look at every comment and I'm just like, okay, is this a personal attack, or is this like an actual comment, an actual critique that I can actually use? Okay, so thank you so much for watching. I don't even know how much I talked. I think it was like 1 hour or 50 minutes. But again, my whole point of this video and of this channel is to teach you fully programming, and it just takes time. And I'm just thinking about, like, my whole vision is to just like do as a teacher. So we have a class, okay? We have a class, we have a daily class over here, and we have that class for 45-50 minutes. and this is your programming class. And I'm trying to teach you how I am taught in my university, for example. We have a 1 hour class. We don't have classes for 10 minutes or 5 minutes, or we don't have classes where the teacher knows exactly with no errors and with no bugs what he wants to teach. No, he goes through the material, he goes through what he wanted to teach, and also faces the bugs and the errors as he goes. So this is my approach to my channel too. I'm trying to teach, to just hold a class, to just hold a 50-minute class, hopefully daily. So thank you so much for watching. I hope you enjoyed this, and I will see you guys in the next video. Bye.